Number 33. How many moles of gaseous boron trifluoride, which is BF3, are contained in 4.3410 liter bulb at 788 Kelvin if the pressure is 1.220 atm? And then they ask a second question, how many grams of BF3 is this? Okie dokie. So it's a little bit challenging to figure out what formula to use, especially in the gas chapter, because there are so many. So in order to combat this, what we're going to do is for gases, we always just like to list out everything that we got and analyze from there. Now they're saying how many moles of this BF3. So that's what we're looking for. Remember, the universal letter for mole is N. So in this case, we're looking for the N value. So I'm just going to say N equals question mark. And then I'm just going to keep going on my merry way until I get to another number. They tell me that I have 4.3410 liters, so that's a volume, right? Liters are volume, so I got a V value of 4.3410 liters. Beautiful. Let's just keep going. Now they tell me that I have a temperature, because K is Kelvin. Kelvin is a temperature, so I have a T value here of 788.0 Kelvin. And then they told us that the pressure, right, if the pressure was 1.220 atm, P is pressure, 1.220 atm. That's all we got. So from this, I don't have any sets of values. I don't have two volumes, I don't have two temperatures, and I don't have two pressures or two N values. If we did have sets, remember, that's always the combined gas law. But here I just have a single variable for moles, volume, temp, and pressure. That's not the combined, that's the ideal gas law, which is this one right here. It's PV equals nRT. Now this one is very specific because the R constant value holds all of the units. So we had to be very specific with our units here. So let's just go from left to right. P, if we're using this formula, the pressure has to be in atm. So we're good here. They gave it to us in atm, I don't have to convert. V, the volume, has to be in liters. Oh, thank goodness. They gave it to us in liters. So far, so good. N is the moles, and that's what we're searching for. So we're good with that. R is that constant value. And that R gas constant is 0.0821. If we did want to know the units, it's atm times liter over mole times Kelvin. That's what I meant by it has literally every single unit in the formula. That's why we have to be very specific. You don't really have to memorize this, just memorize the number. And T, since the R value has Kelvin in there, it's got to be in Kelvin. And thank goodness. They gave us all the right units, so no conversions. All we got to do is just plug it in. So let's go. P, 1.220, times my volume, 4.3410, equals the N value, which I'll label as X. I just like to solve for X, and no other letter. I'm very biased towards X. And then we have 0.0821 times by the Kelvin value, which was 788.0. So in this case, if you want to solve for X, right, what you can do is you can multiply this one number, multiply this, right, to get one number on both sides and then divide. But we want to try to avoid error, or not error, but rounding at all costs. So what I'm going to do is I'm just going to divide by these two numbers just like this, and I won't round in the calculator. So I will plug this all in one shot. But you can do it whichever way you prefer better. And let's just see if our answers are very close or maybe they might match. So with dividing by these two values, I'm basically getting rid of this whole thing. Beautiful. And now I just have to divide by this. So X equals, I'm going to do 1.22 times 4.3410. And now I don't like to use parentheses, so I will divide by this number and then press divide again. Now, if you want to use parentheses, you would say divide by this number times this number, and then close the parentheses in your calculator. So let's see. I'm going to divide by 0.0821, and then I'm going to divide by 788. And let's see, how many sig figs? 4 sig figs is the lowest value. So I'll put it in scientific notation. 8.186 times 10 to the -2. And that's moles of the BF3. Okay, so that's the first answer. So we found out how many moles. Now, they're asking for how many grams is that? Well, that's pretty easy, right? We found out the moles. Now we can just convert to grams, right? We know how to go from moles to grams. That's way back in Chem 1. I think the gas chapter is still Chem 1, but I mean way back, right? We got to use that periodic table. So let's write it out. I got 8.168 times 10 to the -2, and now that's moles of BF3, and I'm going to times by the ratio. I'm going to throw the unit that I don't want on the opposite side, so this is going down on the bottom, right? Moles of BF3, and grams goes up on the top, right? Grams of BF3. A gram to mole conversion of the same compound is always the periodic table. And if you're using the periodic table, remember, you only have 1 mole. So 1 mole of BF3 is whatever the mass is on the periodic table. So I have 1 boron and 3 fluorines. I'm looking at my periodic table. Let's see. 19 times 3 plus 1 boron is 10.81. So I get 67.81. Cancel out the moles. And now that number times 8.168 times 10 to the -2. And 4 sig figs again. So I have 5.539. So 5.539, and that's grams of the BF3. And that's it. So seems like we're combining a lot of chapters now. So we did grams or mole to gram conversion. We're doing the pressure. And then if we had to convert these, that would be all the stuff that we learned before as well. So hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you would like to help us out. That would mean the world to me and my brother. And thank you so much for that. And I hope you guys are having a great day. Let's keep studying hard, and I'll see you in later lessons. Bye-bye.